Hello everyone. In this video, we will understand Retrieval Augmented Generation, commonly known as RAG. A large language model, or popularly known as the LLM, normally answers a question based on what it learned during the training. But the problem is the training data may not be up to date, or the training data may not have latest information or say specific details, say from a document or a manual or an external database. Now, RAG solves this problem by connecting the large language model to external knowledge sources. This will make the large language model not entirely dependent on the training data. Now, the sources from which the information is sought can be from PDFs or manuals, lecture notes of experts, or external databases. Now, so instead of depending only on its memory, the AI first looks up for useful information and then it will answer. This makes the answer more accurate, uh, more up to date, and most importantly, it will make the answer explainable. So the meaning of RAG is quite simple. First, retrieve relevant information. Second, add that information to the user prompt. And third, generate an answer that is based on this retrieved evidence. So this is how RAG works. Now, let us look at large language models that work without RAG and those large language models which are RAG enabled. Let us look at the difference between both. Now, a large language model on its own can give general answers. Say, for example, if I will ask the large language model, what torque value is recommended for this coupling, the large language model may give me an answer saying that the value is usually between 50 to 100 Newton meter. But then we see that while the answer sounds proper, it is not specific and it doesn't give you any source from where you can verify this. Right now, if you ask the same question to an RAG enabled large language model, what the RAG will do is it will search for relevant maintenance manual or technical document which will have data to answer this question. Then it will retrieve the exact information and it will generate a more grounded answer. Say, for example, it may give you a response stating, according to the maintenance manual, section 4.2, table 3, the recommended torque value is 72 Newton meter. Right now, it is very clear that this will make the response more explainable. Okay, so this is the key advantage of RAG. It will reduce hallucination. That is, it will reduce confident but unsupported answers. Okay, as a user, we can now trace back the response to the original source. All right, so next up, we will look at the RAG workflow. Okay, how does a user query get transformed into a grounded answer from the large language model? What is the process? So let's look at that process. Step number one is the retrieved documents by the RAG is been split into smaller pieces known as chunks. Now, that is step number one. Step number two is each of this chunk is converted into a mathematical form which is known as embedding vector. Now, what this embedding vector will represent is it represents the meaning of individual pieces of data. The third step in the process is the user query is also transformed into an embedding vector, right? And in step number 4, the system performs a similarity search, meaning it will the uh, match the embedding vectors of both step number 2 and 3. Okay, so from the vector database, it performs a comparison and it will retrieve the top k relevant pieces of data. Okay, that is after matching the query vectors with the information vectors, it will select the most relevant pieces of information. All right, now using this piece, using these retrieved embedding vectors, the prompt will now be modified. Additional context will be added to the prompt now, right? And this modified prompt will then be sent to the large language model, right? And based upon this modified prompt and based upon the additional information which is obtained from external databases, the large language model will now provide you with a more grounded and more accurate information. So this is how RAG works. Now, moving on, let us look at a mechanical engineering application. Say, for example, as a user, I am asking a RAG-enabled large language model, why is this centrifugal pump vibrating excessively? If that is the query that I will ask, now that will be first sent to the RAG. Now, what will the retrieval augmented generation system do? It will first of all look at additional knowledge sources. It will search for pump manual, maintenance history, alignment procedures, fault logs, and so on. Right? And based on this additional, data that it is able to retrieve, right? Say for example, it will learn and it will retrieve reasons for vibrations such as misalignment, cavitation, worn out bearings, loose foundation bolts, and so on. Right now, based on this retrieved information, the prompt will now be suitably modified, and that modified prompt will then be sent to the large language model, and we may get a more grounded answer from the large language model saying that the user should inspect shaft alignment, and we should check for suction conditions, right? Look at worn out bearings, right? And it will also say that refer to the manual, so and so manual as reference, right? So what happens is, instead of general uh, you know uh, information, the RAG enabled large language model will give you very specific maintenance procedures, right? So an RAG enabled large language model can therefore be used for maintenance, design support, lab learning, report preparation, and so on, right? So RAG is essentially large language model intelligence plus external knowledge. Thank you.